I'm Sergiusz. Nobody can spell that name, so just call me Serge. I think that's much easier. And this is Stefan, and we're both engineers at Mesosphere. So we are the guys who are programming, essentially. So we're not professional presenters, so I'm sorry for that one. Yeah, we are engineers at Mesosphere and working on the Kubernetes and Mesos integration. You've been hearing from Brian about the awesome Kubernetes project, and we are responsible for integrating this stuff in the Mesos scheduler infrastructure. And we're also responsible for the DCOS integration. You see like nearly half of the team. The other colleagues are sitting around the world. And Tyler is not a dragon, I promise, but this is his avatar. Yeah, so that's us. We're working on Kubernetes Mesos. It's all open source. It's all written in Go. It's all fully and upstream. So when you go to the GitHub page that Brian showed you, you will find all the source code up there. What is Mesosphere? So basically, Mesosphere is the company behind those components which you see here. So I'm just interested. Who of you have ever heard of Apache Mesos before? Oh, OK, that's cool. That's a lot. Who of you have heard of Marathon? A little less, yeah, that's kind of what I expect. Kronos. That's approximately the same. DCOS. Oh, OK, so that's interesting to see. I have to give this feedback back. That's very nice. So, OK, so many of you have heard of Apache Mesos. Apache Mesos is what we call a distributed systems kernel. It's essentially a scheduler for launching arbitrary tasks in a clustered environment. And the other components listed here have other tasks. Marathon is a framework which runs on top of Apache Mesos and is responsible for running long-running tasks. Kronos, as the name says, a cron replacement for things that run in intervals. So DCOS is the thing that integrates all those components and ties them all together in a nice integrated environment. And what that all means, we will say just in a second. So the challenge which we want to help you with is, to enable data, to enable warehouse computing. So essentially, I really like this picture, and probably you've seen it very often already. But one thing I really like about this picture is that we like to treat the data center as a set of arbitrary machines which can be replaced, taken out and in, and your software still runs, right? So you heard about Kubernetes, and this is exactly the same goal we're trying to achieve. The sad truth in today's data centers, and I took this from a Wikipedia page, I don't know if you see this, it's what we call static partitioning. So you have a data center, and you have label attached to your hardware, where you have your mail servers running, I don't know, dub servers, mail, and so on and so forth. And this is the model we would like to get rid of. And the infrastructure that we try to provide enables you to do that. So speaking of metaphors, who likes doing stuff on Linux here? So yeah, cool, nice. So I also do Linux since a long time, and essentially, what is Linux? Linux is a kernel, right? So is that enough to operate your computer? Apparently no. On the basis of your computer, you have resources available, right? You have memory inside of it, you have CPU, you have storage, and so on and so forth. So the kernel, is the thing that orchestrates those resources and provides scheduling and provides isolation and so on and so forth. And you have different choices for those kernels, right? I like Linux, but there are others too, right? I mean, there's Darwin, there's Windows, FreeBSD, and others to choose from. But there are other components which are responsible that your computer functions as a whole too, right? I mean, and especially these things are layered. So you need something that is able to boot your system. So something that we usually call init.d. Yeah, the good old System 5 boot process and the brand new System D stuff and so on and so forth. And on top of that, once your system is loaded and booted up, you have other components responsible for different things. Like you have a cron daemon running things in intervals. You have a terminal abstraction, mostly a pseudo terminal today. Then you have other user space programs running, like databases, MySQL, and so on and so forth. And when you're doing development, I mean, who of you does Docker-based development? Yeah, so you run, of course, Docker and other things that compose those images, those Docker images on your local machine, like this guy here, the Docker Compose stuff, and runs your containers on your single computer. So taking this metaphor and putting it on a data center level, makes it something like this. So essentially, what the DCOS is all about is taking the kernel, which we see Apache Mesos being responsible for, taking the init.d daemon, the thing that boots your thing, which is Marathon, Chronos as the cron abstraction, command line tools replacing your classical terminal, and Kubernetes, actually, which runs your containers. So, and instead of handling, a single set of cores on your single computer, the Apache Mesos scheduler is something kernel-like that handles all the CPUs in your available data center. And the nice thing about this abstraction for me is that it doesn't treat your machines in the data center as single instances, but rather a set of resources which it can take, CPUs from, or storage from, and memory from, and put it in the responsibility of Kubernetes to launch pods, for instance. And the base idea, for instance, of a Linux system, you have many distributions to your disposal. You have, I don't know, Ubuntu, Debian, Red Hat, and so on and so forth. And this is how we look at DCOS too. DCOS is simply a distribution, and theoretically, you could build your own, which would be actually a nice open source project. Take those components, put them together as a distribution, which is installable in your data center, and puts all those things in a nice packaged way, such that, as Brian described, you don't have the hassle of thinking about the network and how these things compose together. It's all hidden away behind this distribution, which is easy to install and easy to maintain. And Kubernetes, in our point of view, running on this DCOS, is something that I see as a metaphor to userland APIs or userland programs. So from the perspective of DCOS, your containers, your pods, simply are program or process instances running on this virtual operating system. And apparently, all those descriptors, and these are those YAML files from Kubernetes, are simply descriptors for your program to run. And this is how you declare your relationship between your process and the data center operating system. So again, the challenge, warehouse computing, and when you boot up an arbitrary operating system and you have a system monitor, which you usually call like using top or more in graphical environments, this is the stuff that you see on the DCOS. A high-level overview of the resources available in your data center, which shows you in a quick overview your CPU allocation, memory allocation, failure rate, and so on and so forth. And Kubernetes is a subset of this in this case. You can drill down more and even see those individual units running arbitrary processes in your data center. And I really like this picture because you still see somehow in an abstract way your individual nodes and the CPU utilization of the processes and how they run on it. So how does Kubernetes come into play? We want to make this integration of DCOS and Kubernetes as simple as possible. And it doesn't matter whether you run DCOS on Amazon or on-premise on your own hardware in your own data center. Everything you saw on the talk before with the kubectl command, when you have a DCOS instance running, the only thing you have to do is you have to put DCOS in front of it. So DCOS space kubectl and all the commands that you know from interacting with Kubernetes. And instead of launching those pods on a raw Kubernetes instance, those pods will be launched on an Apache Mesos cluster, orchestrated with DCOS operating system distribution. And hopefully, may the demo gods be with us. I hand over to Stefan. He's going to show you how all this jazz works.
Yeah, so we prepared, not a huge cluster, but a cluster with 20 machines. Can also create a one with 100 or 1,000. It's running on AWS at the moment. So this is a live view of this DCOS screen, which you saw before as a screenshot. So there's not much work done at the moment, 37 tasks, and you can see the services running here, so some big data stuff, some HDFS, Kubernetes, some Spark, but there's not much really going on. So if I go back to this nice grid view, which we saw before, you see they are pretty empty, and we want to fill them. So what I did before, when you look again on the slide, I did the installation already. So it's really just this command, and it takes a minute or so until the Kubernetes is really installed and up and running. So I did that before because it takes a minute. But otherwise, you have a clean cluster here, a clean Kubernetes cluster. So I just give you a feeling of that. So you have the kube control, which is a bit too big. I hope you can still see it. So Serge said something, you have to prefix that. I made a prefix, or an alias, in fact, in my bash. I can say kube control just like that, and I can do similar things that Brian already showed. So I prepared one example, very simple Nginx instance. I want to scale that. Imagine, of course, this is not, usually it's not on the AWS system. It should be on your data center somewhere, maybe on your own bare metal, but it's not a pre-installed or pre-configured installation of Kubernetes like in the Google Cloud. So this is more like for enterprises. That's the main idea. I have a template here, in fact, the replication controller of an Nginx pod. I just launched that. There is a create command against the YAML file, and you do that. Takes some seconds until he creates all the resources on the controller, on the API server, sorry. And here on the left, I see the pods. And at the right, if you can see that here behind the screen, there's a replication controller. So the left thing is just describing how the replication controller looks like, and at the left you see the pods. And at the moment, we have replicas set to 3, so there are just 3 pods. I mean, we can look for them here somewhere in our, where is it? It's here, so it's somewhere here in this, on one node. We can just say kube control, get pods, and just take one here. And in fact, we could find out where it really lives. But usually you don't do that. So you can say something like that, and you get all the data, all the JSON, the whole description of this thing, and somewhere in this JSON there is really the node, but usually you don't care about that. It's one big computer, and it's running somewhere, and if it's killed or it crashes, it's restarted somewhere. It's all what Brian described. It's done by this replication controller. You can scale this thing, so it's the same command, basically, what you do in the Google Cloud. So I have a 20-node cluster, maybe 150 instances of that is not such a bad idea. I just say scale. It takes a moment. He creates the pods, all the 147 missing pods, which we didn't have before. And you see on the left here, it's filling up quickly. At the moment, everything is pending, so it takes some time. And here at the right, you see 5 are running, 145 are waiting, and it's just a watch, so it takes 3 seconds or so to update. And you're seeing here they're coming up pretty fast. And what you see here, so they should slowly go up, I hope. And the tasks are started here on some nodes. I just showcase some features here. So we have those frameworks, and Kubernetes is one, so you can just go here. You see it's not taking so much CPU yet. There's some memory, and the task, I think I have the wrong instance here. 1 second. Which one is this one? Okay, I started 2 clusters just to showcase. I think I have the wrong here, so you don't see it in the UI. No, we lost the network, apparently. So much about the demo gods. Okay, it's back. So on the other cluster, we would see all the 150, so this is not really a match with this output here. And we can also open the UI of Kubernetes. I'm not really sure it works here. Apparently it doesn't, so the demo codes are not with me. Yeah. I think we have a network problem or anything, because we don't see any update here anymore, not even errors, so. Okay, I cannot debug that here on stage. Anyway, so those go up, and usually 150 within 2-3 minutes, they are started running on those nodes, and you can just access them using load balancer or anything like that.
Okay. So, again, when you see it from a layered view, we have Mesos at the very bottom, acting something like a kernel, which does the scheduling part and the allocation part. Then you have the DCOS as a virtual operating system wrap around it, and Google up there. And if you're a little bit more interested in how that stuff internally works, we try to give you a very high-level overview. So first of all, Mesos, which is responsible for the actual resource management, for the scheduling, and so on and so forth, looks a little bit like this. So essentially, you have Mesos running, and mostly also in high availability mode, as master instances, persisting its state into Zookeeper. And what frameworks do, which is what we call, which is our terminology for the stuff that you usually call user space applications on a regular operating system world, interact with the Mesos master with an SDK, which is, in our case, HTTP and protobuf based. So, and a framework in this instance is Kubernetes. But there could be arbitrary frameworks. So we have much more, like for instance, Elasticsearch or Cassandra and so on and so forth. And how that then works is that you have your physical machines, your nodes, that stuff that we try to abstract from you, and each of those machines runs Mesos agents, which actually have two responsibilities. First one is gather all the resource information from the given node. For instance, it has 4 cores, 3 gigs of RAM, and so on and so forth. And the other thing is it launches what we call executors. And in this case, this would be executors from the framework. For instance, Elasticsearch or Kubernetes, and arbitrary subtasks, which would be in the Kubernetes world parts. And speaking of Kubernetes, I think there is a very nice, match between those two worlds, because you can pretty easily apply on what a Kubernetes master does, which is the canonical example of a Mesos framework, actually, right? So the only thing we did is we took out the core scheduler of the Kubernetes and replaced it with the Mesos scheduler, and everything else works the same way as from a native Kubernetes installation. And the Kubernetes executor actually is just a kubelet, right? So that's the only thing that has to be launched by the framework on the given node. And the tasks from Mesos are essentially the parts that you want to launch. So therefore, we believe there's a very nice, overlay of those two concepts, and therefore those two things go hand in hand and very nice together. So when you call the kubectl command, the only thing that happens is that we prefix all those URLs that the kubectl command speaks to the API server with /server/Kubernetes, which is the framework name. And everything else stays exactly the same as from a native Kubernetes installation. So again, DCOS provides all the packaging infrastructure behind all this. So you just type a simple command like apt-get install Kubernetes, you type DCOS package install Kubernetes, and it does all that for you. And it provides all the other high-level services. If you want to try it yourself, it's pretty easy to spawn a DCOS cluster on Amazon. But you can also do it on your machine. And as of yesterday, we released a new Kubernetes version, Kubernetes on Mesos version, which our internal version is 0.7.0, which is based on the upstream version 1.1.1. And here are some links for you. So if you are interested into starting Kubernetes on an existing DCOS cluster, you have those URLs here, which you can look up. If you want to try just the Kubernetes on Mesos part on your own laptop, which we all the engineers do all day, there's also a very nice getting started guide for doing so. And then you also can look up our own code, which work on a daily basis on the GitHub itself. So, in terms of roadmap, I give the word to you.
Yeah, we are often asked, where are we? So we are at the 0.7 at the moment, so it's not production ready. We're working hard on that in the team, and so 0.7 is just a day old. Yesterday evening we did that, and we plan another one maybe in 2 weeks or so. And we have a kind of, we call it MVP internally. It's a 0.8 version which has everything, so you can really deploy it on a cluster and start with maybe non-critical applications. So it's a better version essentially. And somewhere, I don't know, in Q1, Q2, something like that, next year there will be a production-ready version. That's our plan at the moment. Yeah, and of course it's pretty important. So we are still a small team, but we are looking for people. So we have an office. At the moment it's not so big, it's just search, but we are looking in Berlin for people. Originally the company is from the US, from San Francisco, and we have a big office in Hamburg, and now we're starting here in Berlin. Or we did that already for a few months, and we are trying to grow the office here. So if you're interested, just come to us and ask us about some details. Yeah, and you have seen the links already, so you can see everything what we did before, just with the Docker Compose setup. That's the second link, for example, on your notebook if you want to play with it. It's not so huge, not so complex. It's really just a, 100-line Docker Compose file with some services, some containers. Yeah, and I think that's it from our side.
Pretty much it.
So we are open for questions.
Okay. So we have a lot of time for questions, so feel free to ask one. Question, why should I run Kubernetes on Mesos instead of natively?
So we didn't stress that so much. So you saw this DCOS screenshot or the live version where you had all those services on the left. Like there was a Cassandra running on that, which is also possible kind of in Kubernetes. We had a number like 6 or 7 services. So the whole idea is that you can share the cluster with different frameworks. Like you can have your big data stuff all in this framework, which is not possible right now really in Kubernetes. So you can have Spark or Kafka or whatever. So you can share all the same resources. They are just living next to each other. And you saw those circles, 20 circles for the 20 node cluster. And the colors were just a framework. So they can really run on the same node. That's the basic idea.
Okay. When should I use Kubernetes and when should I use Marathon?
There are basically 2 APIs. So, I mean, Google is stressing that all the time. The main contribution of Kubernetes is the API, which means the concepts. What is a pod, what is a service, and so on. And Marathon is just another one. So we don't see some, I mean, there are cases where Marathon is more advanced at the moment. They have really quite a good rolling update feature, for example. They have grouping, so a hierarchy of tasks. So there are things which are good in Marathon. There are other things which are good in Kubernetes, but they're really pretty similar in the concepts and in the purpose. So use the one you like, use the one which fits. You can have both, and you can have even one part of the application in Marathon, one in Kubernetes. They can speak to each other. That's fine.
There is another question. Does your Kubernetes framework also support the Kubernetes IP per container feature?
Yes. So it's possible to run a Mesos cluster with container IPs. There's a Calico collaboration. And it's also possible to use something like Weave, if you know that, some overlay network, it's possible. And the only difference we have between container IP and not container IP, it's our endpoint controller. It's one of the many controllers that Brian mentioned. It's the one which connects pods to services. And this is a bit different, just 3 lines of code. That's the only difference. If you replace that by the normal one, you can use container IPs.
Yeah. Seeing the feature question, do you have like a quick overview either now or you can point to a place that or states which features of Kubernetes are not yet supported by your framework, and which features are you have in Mesos Marathon that are not yet in Kubernetes? Is there a comparison like that somewhere?
Yeah, there's not a table, but there's one pretty important property of our last release. So the big thing of the 0.7 release is conformance, which means there's a big test suite which checks that a cluster is really conformant to what Kubernetes promises to do. And we are compliant to that with our development cluster. We plan to do that with maybe 0.8, something like that, with the DCOS package. And we want to pass all those tests. That's the goal. If you want to look what doesn't work at the moment, there in the documentation, if you follow the links we had there, there's the issues file, issues MD. It's in the GitHub repository in the Mesos part. There's a lot of text describing where the differences are.
Okay,
Sorry, we had a question here in the audience.
It was in conjunction with a marathon. That's maybe
What is the? So your question is, what is the conjunction with marathon?
the question is on your picture. You said it says Kubernetes on top of marathon. Is that correct? Do I need marathon for Kubernetes? Or?
No. So we use. So the question is, the slides showed that Kubernetes runs on top of marathon. That's technically a little bit different. So we do use Marathon as the canonical init.d daemon for launching Kubernetes. So Marathon launches Kubernetes, but it doesn't technically run on top of it. It runs next to it, if you want to say it. But we do use Marathon in order to launch a Kubernetes cluster when you do a DCOS package install Kubernetes, yes.
It's just the init.d component of DCOS,
Yes.
which we use. That's it.
There's another question which regards the different consensus systems which run in parallel on the Mesos level and on the Kubernetes level. Are they affecting each other somehow? Is there anything that's
There's hardly any connection. So, I mean, the main purpose of etcd here is just the persistence. It's the state storage for the API server. Otherwise, they're independent. So, of course, Mesos has leader election, all this stuff, and yeah, and we have the same for our scheduler, which uses etcd at the moment, which might be changed soon, but so they're not connected, no.
Okay, there's another question which is quite interesting about kind of developer responsibility or developers versus DevOps responsibilities. So it says Docker is actually separating the infrastructure concerns of running Docker daemon on a host from the kind of application level concerns where I deploy containers or manage containers. Looking at Kubernetes, Mesos, and Docker Swarm and Fleet and all the other things, it pulls more of the infrastructure concerns again in the picture. What do you see kind of when you look at that in real world projects? Is it actually so that there's a separate people setting up, for instance, Mesos with Kubernetes, and then the application developers just deploy on top of that? Or what kind of setups do you see how they're used in practice?
I think it's a kind of platform. I mean, it's usually deployed by some platform people. They can be the same. I mean, we have a colleague who does both things. He deploys applications in a huge dimension, but he also deploys the Kubernetes. I mean, at the end, it's a platform, and it can be used by developers, and they have a lot of flexibility and a lot of insight, which is important. So they can really go into the container and debug it themselves with another bash process. They can really dive into the things they are running. So they can do something like DevOps, if they like.
Yeah, question here is the kind of experience level kind of the same that you need for kind of setting up and fine-tuning like Mesos, and kind of configuring your applications, which is kind of on a different level of experience? Or?
It's probably different. I mean, Mesos, the main audience of Mesos is to have a lot of nodes, like 1,000, 5,000, 10,000. That's the dimension. I mean, that's the target audience of Mesos. Yeah. So that's a different kind of knowledge you need than compared to an application developer, of course.
And I think, having said the concern of knowledge, I think that's exactly the thing that DCOS tries to abstract from you. So when you use Debian on Linux, right, and you apt-get, you don't exactly know what pre-scripts, post-scripts are being run on it, right? And you don't know actually, You just type the command in, and the thing is being installed. And I think DCOS helps you a lot with that complexity. Even if you are running such a cluster, you just say DCOS package install the same way as you do an apt-get install.
Yeah, okay. Last question that I see here is, how do we support capacity planning, for instance, on AWS, on other services, when you have the ability to, scale the underlying infrastructure as a service independently without pre-allocating machines, for instance? Do you have things like that?
Honestly, we should take that question with us. Yeah.
Yeah. Okay.
Cool. It's a good question. Yeah.
Otherwise, any questions in the room? Cool. Then thank you for your talk. Don't forget to rate, of course, and thank you for being here and presenting. And you can enjoy your break and then come back for the closing keynote. Thank you.